There's also different types of veins. And what's shown in this picture is just pretty simple, large veins. So they're bigger, medium-sized, and then the venules, remember we've talked about as the small veins. And those all have different thicknesses of the different layers. So basically large versus medium, you're gonna have thicker layers in the large, and especially that intima looks different. I don't need you to know really that the whole thing is bigger. Both large and medium veins are pretty floppy, as you remember from that histology slide. There's definitely less tunica media, that smooth muscle, compared to arteries. The other thing that's important in medium-sized veins is valves. There are valves in them. We'll come back to why these matter. And lastly, venules are just going to be smaller. They're thinner overall, thinner, each layer is thinner. So that's all about veins in terms of histology. You'll compare them to arteries, or you already have in lab. So what we want to talk more about veins though is their function. So if you remember, velocity in the veins actually increases despite the fact that blood pressure has gotten really low. So blood pressure is dropping throughout all of circulation, but we still need a way to get blood back to the heart. Well, first of all, it still is above zero. So as long as our atria are close to zero, which they are, but not all the time really, we want to be able to have ways to get the blood back to the heart. So that's what we're going to focus on now, and that's called venous return, is how we return blood from the veins back to those atria. So venous return relies on a couple different anatomical things. One is a muscular pump. So what I mean by that is the muscles being a pump. The skeletal muscles act as a pump. I'll show you a picture of this. And then this is also going to be related to our valves. So the skeletal muscles, this might be your gastrocnemius, the calf, or whatever. As those muscles contract, so here they're relaxed, here those muscles contract, that actually pushes, it pumps the blood back to the heart. It's going to the heart because the valve that is distal is closed. The valve closer to the heart opens. So the valve opens, that muscular pump, the skeletal muscles actually act as a pump to squeeze the blood back to the heart. And then as you exercise, for example, this happens even more and aids in venous return. So that's helpful. Once the blood passes by this valve, it's a one-way valve, so it can't return again. So blood's only going to go one way to those atria. The other type of pump is a respiratory pump. This is pumping that occurs from breathing as you increase and decrease the size of your thoracic cavity. We'll look more at that change in volume of your thoracic cavity in the next unit in respiration, but I do want to just show you a picture here to have you start thinking about that, because we'll get there, and also to have this idea of just, it's a pump. That's all you need to know for now. The diaphragm and ribs are going to move up, so the thoracic cavity is going to get bigger and smaller. So bigger, smaller as you breathe in and out. That's going to increase and decrease pressure in the blood vessels, the veins, and allow for a pumping action as well that facilitates the return of blood to the heart as well. Yeah, so those are the two pumps, and as well as what the valve does. And again, you need these pumps because blood pressure is so low, these pumps are going to facilitate venous return. And both of these things, both respiratory and muscular pump, are going to be increased during exercise when you need quicker venous return. The other thing I want to talk about with the veins is venoconstriction. What's venoconstriction? Constriction of the veins. So it's a type of vasoconstriction. I would like us to call it venoconstriction so that we don't mix it up with the constriction of the arterioles, because the effects of it are different. this is going to be regulated by the sympathetic nervous system that we'll see next week. So there is smooth muscle present in the veins. So the smooth muscle is going to constrict. And here's the confusing thing. When the smooth muscle constricts, remember how veins are kind of floppy? Let's draw the smooth muscle of a vein that's relaxed. And then when that constricts, so try to draw it about the same size, but it actually gets rounded. What do you think rounding out a blood vessel does to its resistance? This is going to decrease resistance. So when you have constriction of the veins, you actually have decreased resistance. What does that do to flow? You have increased flow. And that is different than what happens when you constrict the arteries, which also makes sense, but keep them separate. Different mechanism here, we're changing resistance. So when you have constriction, increased flow, you're going to have increased venous return. Yeah? Okay. When you're exercising or stressed out, your veins actually act as a blood reservoir. They store about 60% of your blood is in your veins and venules. So when you need it, when you need to have more venous return occur, let's say that you're exercising, all of a sudden your skeletal muscles need more blood. You can quickly venoconstrict to increase venous return and have that blood flow go out again in stroke volume. So that's the venous reserve or blood reservoir that's in the veins. It's then activated or can be utilized by activating venoconstriction.